Hello everyone and welcome back to Mr. Anderson's Algebra 1 lessons, and today we are going to be completing the square. Now, completing the square is just another tool in our arsenal of being able to solve a quadratic equation, and there's really two reasons why we would use completing the square. First, if we don't like factoring, we can use completing the square to solve our quadratic that we're given, or if we don't know the quadratic formula just yet. So it's really kind of the step in between factoring and knowing what the quadratic formula is, which in a few videos from now we are going to take a look at what the quadratic formula is. So let's get right to it. We're going to start off with a simple example here. And when we're using completing the square as a method to solve a quadratic, there's 7 to 8 steps that we need to follow, depending on the size and difficulty of our quadratic equation. Now, we're assuming and we know that this quadratic equation, a is 1. A is less than or equal to 1. And so that means we can really kind of not do one of the steps, and I'd like to start off by doing step 1, which is setting the equation equal to 0, and then move C in the equation, and C is this last number here, and moving C to the other side of the equal sign. And so what that does is it frees up the left hand side to be putting in our square, so to speak, because what we're doing is we're turning this quadratic into a perfect square, which is something that's really easily factorable, and it's able to break down really nicely using square roots. So we have this space here, so that's step 1, is to move C over to the other side and make sure the equation is set equal to 0. Now step 2 is the one that I'm mentioning that we might not need to do, and that's because we have to factor out A from the left side of the equation. Well, in this scenario, A is 1, and when you factor out A from each term, you just get itself. So step 2 is just to basically leave this alone for this example. Step 3 is you divide both sides by A. So in this case, you're just going to divide by 1 to both sides, and again, that just kind of negates itself because it's still equal to the same thing. Now, if A in front of this was a bigger or larger number, that's where you would see step 2 and 3 that we just did. Now, step 4 is a little bit of a complicated one. And what you do here is you need to take half of B divided by A, and then you square that and you add it to both sides of the equation. So for this, we actually need to know what A and B are of our quadratic equation, and we should have wrote that first, but it wasn't really necessary in the start. So C was 17, we figured that out. B is 16 and A is 1. And so for step 4, we have to take half of B divided by A. So B divided by A is equal to 16 divided by 1, and so that's just 16. And they want us to take half of the 16. So this is where it begins to get complicated. So 16 divided by 2 is 8. And now that I've got half of my B divided by A, I need to square that. So that 8 needs to be squared. So 8 squared, that's 64. And this number is what you add to both sides. Now remember, when you're doing algebra, what you do to one side of the equation, you have to do to the other. This ensures that it creates balance. when you are solving. So we didn't really change the value of both sides here. We just made it equal. So now what you should notice is when you have this side over here, this is what we call a perfect square. And this factors very nicely. Okay? Now this side we'll talk about later, but we are now in a good position to factor and clean it up. So what you do for the fifth step is you factor this side and you combine like terms here. Now this is why we call it a perfect square, because when you find the two numbers that multiply to 64 but add to 16, you get this. Okay? But when we do that, we don't like writing the same thing twice, so it actually breaks down to x plus 8 quantity squared. And that's why we use that perfect square, so we can turn it into this. Now if you solve this nicely, you can just square root it to get rid of that square term. And that's why it's really nice. So now we clean up the other side. We take 64 plus 17, and we get 74 plus 7, which is 81. And look at that, really nice. 81 is going to be really easy to square root because 81 is also a perfect square. So to finish solving, that's actually step 6 of this, is to solve for x by taking the square root of both sides. So square root over here and square root over there. Remember, what you do to one side of the equation, you have to do to the other. The square root and the square cancel, and you're left with x plus 8 is equal to the square root of 81. Now this is a new thing in algebra where a lot of us don't realize when you take the square root of a number, there's actually two answers. There's a plus answer and a minus answer. And that has to do with the fact that there are two things that you can multiply together to get positive 81. And I'll show you that in a minute. When you take the square root of 81, you will get 9. So you have plus or minus 9. Now back to that little tangent I was talking about. Why there's this plus and a minus. 9 times 9 is equal to 81. But negative 9 times negative 9 is also equal to 81. So that's why when you square root this 81, or any number so to speak, you have a plus and a minus answer. Okay? So you should remember that moving forward. Now what I'm going to do here is I'm just going to solve for x. I'm going to subtract 8 to each side. And I'm going to have two answers. X is equal to 9 minus 8. And I'm going to have x is equal to negative 9 minus 8. So my first x is equal to 9 minus 8, which is just 1. And my second x is equal to negative 17. And that's what you get when you complete the square for this example. Okay, I'm going to finish up with one final example here, and I'm going to use this as an example. I'm going to use, let's see, x. Let's see, we got x squared. X squared plus 8x plus 12, and we're going to set that equal to 0. So that's the equation that we're going to use here. And so we're going to just follow the same steps. Okay? So I'm going to scooch this thing up so we can all see here. So we have x squared plus 8x plus 12 is equal to 0. And we are going to be, first off, we're going to find a, b, c. You got 1 for a, 8 for b, 12 for c. First step, remember, is to set it equal to 0, and move c. So we're moving c to the other side. You got x squared plus 8x is equal to negative 12. Alright? Then we need to divide by, or factor out the a. In this case it was 1. So factor out a. Then divide a to each side, which is 1. So that really doesn't change anything. And now I need to find that perfect square that goes here that I'm going to add. Remember, you're going to take b divided by a. So b divided by a, that's 8 divided by 1. And you're going to get 8. And then you take half of that b divided by a. In this case it's 2. And you get 4. And then you have to square that. So when you square 4, you get 16. And that's the number that you are going to add to this side and to this side. Okay? So once I've done that, I've made my perfect square here. And now I'm going to factor this. So the two numbers that multiply to 16 but add to 8, that is x plus 4. And I'm just going to turn it into that perfect square. So x plus 4 times x plus 4 can be rewritten as x plus 4 quantity squared. And that is equal to negative 12 plus 16. In that case, that is just 4. Okay? So now I'm going to square root each side to get x by itself. And you get x plus 4 is equal to plus or minus 2, because the square root of 4 is 2. And now I'm going to subtract 4 to each side, and you get your two answers for x. You find that x is equal to negative 4 plus 2, and x is equal to negative 4 minus 2. So over here, x is equal to negative 2, and over here, x is equal to negative 6. So there you go. That's how you complete the square with those two examples. I hope you enjoyed watching this video, and tune in on the next video to see some more completing the square, but difficult examples. Hope you have a nice day. Peace out.